A dinosaur-killing asteroid is probably the first thing you picture when someone says, the end of humanity. It is also one of the least likely things to happen in your lifetime. That is the theme of this list. The threats that look the most like a movie are often not the ones that deserve the most attention. First, an asteroid or comet. 66 million years ago, Chicxulub helped end the age of dinosaurs, so the mechanism is real, but it is not a roulette wheel spinning every Tuesday. NASA says no known asteroid larger than 140 meters has a significant chance of hitting Earth in the next 100 years. More importantly, an asteroid is one of the few natural disasters we can see coming. NASA START mission proved that a spacecraft can change an asteroid's orbit. Give us enough warning, and the answer may be a tiny shove in space, not a heroic last-minute drill through the middle of a rock. So the century-scale risk is low, the onset would be fast, and the damage would be very hard to reverse. Terrifying? Absolutely. Top of the practical danger list? Not yet. Then there is the Supervolcano. Yellowstone is the version people love because it sits under a national park and makes the apocalypse feel like a road trip with bison. The U.S. Geological Survey puts a crude annual estimate for another Yellowstone caldera-forming eruption at about 1 in 730,000. It also warns that this number comes from averaging only 3 ancient eruptions. Yellowstone is not a clock, and it is not overdue. A giant eruption would be awful. Regional ash, global climate effects lasting years to decades, and a lot of disrupted food. But awful is not the same as everyone dies. If you like catastrophe explained without a fake countdown clock, subscribe. The useful question is never, could this happen? Almost anything can. It is. What would we notice? How fast would it move? And can we still do something? Gamma ray bursts are where the universe gets properly rude. A massive star collapses, or 2 compact objects merge, and for a few seconds it can fire an absurdly narrow beam of high-energy radiation. If the beam hit Earth from close enough, it could damage the ozone layer and hammer life with ultraviolet light afterward. NASA has discussed possible effects out to roughly 10,000 light-years depending on the burst. But the sky's not hiding a nearby loaded gun pointed at us. This belongs in the real physics, no actionable warning, drawer, enormous consequences, but no sensible 100-year probability to put on a dashboard. Pandemics are different because they do not arrive from space. They emerge inside a world packed with airports, hospitals, misinformation, supply chains, and people who will absolutely go to work with a fever because rent is due. A pathogen does not need to kill everyone to break things. It needs to spread faster than societies can detect it, protect vulnerable people, and keep essential systems running. But pandemics are also not a magic extinction button. A pathogen? Transmissibility, severity, incubation period, immunity, treatment, and human behavior pull against each other. The deadlier it appears, the more people change their behavior, and the harder governments push countermeasures. The realistic fear is a brutal, unequal global shock, not a virus that calmly deletes every human on the planet. In the next century, natural outbreaks remain a serious risk. A deliberately engineered outbreak is worse because someone could optimize for the gaps in our defenses. That is why the World Health Organization treats biosafety, biosecurity, and oversight of dual-use research as public health infrastructure, not paperwork. Nuclear winter is the most human version of a natural disaster. The bombs are only the first act. Climate models examine what happens if city fires inject soot into the upper atmosphere. In one well-known set of simulations, the extreme case used 150 teragrams of soot. That is not a prediction that exactly 150 teragrams will appear after any war. It is a model assumption, and the uncertainty matters. The mechanism does not. Less sunlight means damaged harvests mean food stress, and food stress spreads far beyond the countries that started the war. This is why nuclear war ranks higher than an asteroid in any sane near-term list. We built the weapons, we know where many of them are, we can launch them on a bad day. The onset could be minutes for the first explosions and years for the food crisis. Some systems could recover. Millions of lost lives and shattered institutions would not. Prevention is not science fiction. It is diplomacy, safeguards, and fewer chances for one failure to become everybody's problem. Climate change and biosphere loss belong together, but not for the reason people keep comparing Earth to Venus. Venus experienced a runaway greenhouse effect. Earth is warming rapidly because of human emissions, but Earth becomes Venus next Tuesday is not what climate science says. The IPCC's warning is more serious and less cinematic. Risks cascade. Heat, drought, crop loss, wildfire, ocean change, species loss, migration, infrastructure damage, and political instability can reinforce each other. That is how a biosphere problem becomes a civilization problem. You do not need every insect to vanish at once. You need enough pollinators, fisheries, forests, soils, and water systems to fail in the wrong places while societies are already stressed. Some damage is reversible over time. Extinction is not. Climate and ecology move slower than a missile, which gives us time to act, but the long fuse is not a reason to ignore the bomb. The science fiction version of synthetic biology is gray goo, tiny robots eating the planet like an all-you-can-eat buffet. The boring version is more plausible and more dangerous: a laboratory accident, a pathogen used deliberately, or powerful biological tools escaping good governance. That does not mean every lab is a doomsday machine. It means capability is spreading faster than every institution. Ability to audit intent, contain mistakes, and respond quickly. The World Health Organization latest biosecurity guidance explicitly treats genetic manipulation, molecular techniques, and AI-enabled risks as issues that need layered oversight. Artificial intelligence gets the loudest arguments because it is the only entry here that is changing while we argue about it. One camp pictures a superintelligence flipping a switch. The other says it is just autocomplete with a nicer interface. Both pictures are too neat. The 2026 International AI Safety Report separates risks into malicious use, malfunctions, and systemic disruption. Some harms are already documented. Other claims are, especially about future loss of control, remain deeply uncertain. That uncertainty is not a free pass, and it is not proof of extinction. AI can make cyber attacks, fraud, surveillance, biological research, and critical infrastructure mistakes scale faster. It can also help medicine, science, and safety. So its practical score is not certain apocalypse. It is high uncertainty, potentially fast escalation, and a level of reversibility that depends on whether people keep meaningful control, monitoring, and shutdown options. Treat AI as a risk multiplier, not as a magic villain with red eyes. Vacuum decay is the opposite problem. In some versions of quantum field theory, our universe could sit in a temporary state, a false vacuum, that might tunnel into a lower energy state. If that happened, there would be no evacuation plan, no bunker, and no reaction video. The theory is real physics. The evidence that our universe is about to do this is not. So it gets the lowest practical rank, maximum consequence, zero useful warning, and no known probability that belongs in a responsible list. Before the final ranking, subscribe if you want more explainers that separate possible from worth panicking about, because the one way humanity definitely ends is also the least urgent one. The sun will not explode tomorrow. It will keep getting brighter over immense time. NASA estimates that in roughly 2 billion years, Earth's oceans will begin to evaporate. In around 5 billion years, the sun will become a red giant. This is a near certainty on a timescale so huge that it should not compete with next century. Risks. It is not a crisis. It is a deadline written in very slow handwriting. So here is the honest ranking. At the bottom of practical concern, vacuum decay and gamma ray bursts. Their consequences could be total, but their odds are unknown or too remote to guide decisions. Then comes supervolcanoes and large asteroid impacts, rare natural shocks with some warning, and for asteroids, a growing chance of intervention. Climate and biosphere collapse are slower, but already underway and partly irreversible. Pandemics and engineered biology can move in months, while nuclear war can turn a political failure into a global food crisis almost immediately. AI does not get a fake precise number because nobody has earned one. Its danger comes from uncertainty, plus speed, plus leverage over other risks. The biggest lesson is not that humanity is doomed. It is that the threats we can prevent are the ones we should stop treating like entertainment. Rocks, stars, and quantum fields make great posters. Our own decisions are the part of the apocalypse with a steering wheel.